Good day, everyone, and welcome to another problem-solving session in Special Maths Academy. And we'll be continuing our discussion of the number theory problems in the series. We're discussing the Nigerian Mathematics Olympiad, the first round, the just concluded first round. Okay. So let's go straight to the problem. So by considering this expression here, x squared minus y, and the brackets, y multiplied by y squared minus x, in brackets, or otherwise, how many pair of non-negative integers x comma y satisfy x cubed plus y cubed equals to xy plus 1 all squared? Okay, so let's go straight to this question. So let's look at this expression here and see if we can relate it, to this expression over here. Okay, so we have x cubed plus y cubed, and let's just expand this here, is equal to x squared y squared plus 2xy plus 1. Okay, and this is equivalent to 0 equals to x squared y squared minus x cubed minus y cubed, and I'll just split this 2xy into two terms, so plus xy and then plus, okay, plus xy plus 1. Okay, so now let's expand this. So when we're expanding this, we have this times this, so we have x squared y squared, we have this times this, negative x cubed negative y cubed, and then we have plus xy. Okay, so we see that that's the same thing we have here. So we have this expression is equivalent to 0 into x squared minus y into y squared minus x plus xy plus 1. Okay, and so we have this. So let me just so this expression is equivalent to this. Okay, so now I'll just keep this somewhere here. Let me just keep it here. So the expression is equivalent to this, because I have a feeling this is going to be much more easier. So I'll just take this to the other side. This is much more easier to work with. The powers are smaller and just makes our life easier. And I personally don't like stress. Okay, so y squared minus x. Okay, so now let's consider some cases. Okay, so the first case we're going to consider, and that's something you can always try when you have the uncontained equations. The first case we're going to consider is when x is equal to y. So what does this give us? So we have x cubed, this becomes 2x cubed, what's on the left hand side, and this becomes x squared plus 1 all squared. Okay, so this is equivalent to 2x cubed equals to x to the 4th power plus 2x squared plus 1. Okay, so this is equivalent to 0 equals to x to the 4th power minus 2x cubed, and I'll just split this 2x squared into two terms, so plus x squared plus x squared plus 1. Okay, so this is equivalent to 0. So I'll just factor out x squared from the first three terms, so we have x squared into x squared minus 2x plus 1, okay, plus x squared plus 1. And see that this here can be factored. This is a perfect square, so we have 0. This is equivalent to 0 equals to x squared into x minus 1 all squared. Write this well, okay, plus x squared plus 1. Okay, so now we have that this here is a perfect square. This here is a perfect square. In fact, this whole first term here is a perfect square, and so it's greater than or equal to 0. Okay, this here is also greater than or equal to 0. So it means this whole term here is greater than or equals to 1, because we have 1 at the end here. So I have 0 greater than or equals to 1, which is a contradiction. So it means x and y are not equal. Okay, so let's consider the next case when x is greater than y. Now look at this equation. It's actually symmetric. So considering the case x greater than y, we even directly consider the case when when y is greater than x. So what I mean is the second case here, x greater than y, is somehow symmetric to y greater than x. Okay, because this equation is symmetric. Okay, so let's just do this. So when x is greater than y, since we're dealing with integers, this implies x greater than or equals to y plus 1. Okay, and so I'll just write it here. So this is equivalent to x minus 1 greater than or equals to y, and this equivalent to x minus y greater than or equals to 1. Okay, so three implications. Okay, so now we have from this expression what is equivalent to, we have that x squared minus y times something gives xy plus 1. So it means that x squared minus y must divide xy plus 1. Okay, so since x squared minus y greater than or equals to 0 by virtue of the case we are considering, and because I mean if x is greater than y, that means x squared is greater than y. So it means x squared minus y is greater than 0. Okay, so from x squared minus y is greater than 0, and we're considering non-negative integers, so take note of that. Okay, non-negative integers, and xy plus 1 is also greater than or equals to 1, because we're considering non-negative integers. This means that xy is greater than or equals to 0. Okay, so it means that xy plus 1, that is what is being divided, is greater than or equals to what the divisor, which is x squared minus y. Okay, so now let's look at xy plus 1. Now x into x minus 1 is greater than or equals to xy, because x minus 1 is greater than or equals to y. Okay, and then x minus y is greater than or equals to 1 from the case we're considering. So when we add these two inequalities together, they give us that x into x minus 1 plus x minus y is greater than or equals to xy plus 1. Okay, and so we can expand this, or rather we can simplify it. This is x squared minus x plus x minus y, which is equal to what? X squared minus y, and this is greater than or equals to xy plus 1. Okay, so let's put this here. So we have that x squared minus y is greater than or equals to xy plus 1, which is also greater than or equals to x squared minus y. So what does this imply? It implies that xy plus 1 is equal to x squared minus y. Okay, so let's work on that. So this gives us that xy plus 1 equals to x squared minus y. And so we can try and solve this as a quadratic in terms of x. So I'll just use ideas of completing the square. We have x squared minus xy. So take this to this side, and is equal to y plus 1. So we have x squared minus xy plus y all over 2 all squared equals y all over 2 all squared plus y plus 1. Okay, so I'll just scroll down a bit, and this can be factorized. This can also be factorized. So this is x minus y over 2 all squared equals to y over 2 plus 1 all squared. Okay, so we have two cases. First case is x minus y over 2 equals to y over 2 plus 1, which implies x equals to, when we take y over 2 to the other side, equals to y plus 1. Okay, so let's just keep this somewhere. And the second case is when they are of opposite signs. So I have x minus y over 2 equals to negative y over 2 minus 1. And we know that x is greater than y, so it means this is already a contradiction, but let's just get what it is. So this implies that x is equals to negative 1. And this is a contradiction because we're talking of non-negative integers. Okay, so now let's put what we have. We have x equals to y plus 1. So let's put it into this expression to find the number of integer solutions we have. Okay, so I'll just erase some things. Okay, so we have x equals to y plus 1. So I'll just put it here. So we have minus y plus 1 into y plus 1 equals to y plus 1 all squared minus y into y squared minus y plus 1. And so this is negative. This is y squared plus y plus 1. Okay, so just have to be careful that we don't make any mistake now. It's equal to y squared plus 2y minus y, so I'll just put plus y plus 1. Okay, we have y squared minus y minus 1. Okay, so we have x squared plus y plus 1 equals to this. So let's just dive in. So since these are non-negative integers, so it means this is greater than or equals to 0. Sorry, this is greater than or equals to 1. As this in the brackets here, as excluding the negative sign. This is greater than or equals to 1. And since these both are greater than or equals to 1, it means we can divide by them. You know, if it was 0, then we'll have an issue. But since it cannot be 0, so it means we can divide. So it means we can strike these two out, and we'll have minus 1 equals to y squared minus y minus 1. So we have 0 is equal to y squared minus y. And this becomes let's go out. So we have y into y minus 1 equals to 0. So we have y equals to 0 or 1. Okay, and we just test to be sure that these two values work. So let's go back to our original equation. So we have xy, from this case xy equals to 1 0 2 1. Okay, so let's just go back. So we have xy equals to 1 0 2 1. So let's see if this works. So 1 cube plus 0, so that is 1, is equal to 1 times 0 plus 1 all squared, so that is 1 squared. So it works. So this first one works. And then let's check for 2 1. So 2 cubed plus 1 cube, that is 8 plus 1, and that is going to be 9, equals to, so I have 2 times 1 plus 1, that is 3 squared. So this works. And since we know that this is symmetric, so if xy is a solution, it implies that yx is also a solution. So it means in fact 0 1 and 1 2 also work. So we have 4 possible solutions, and hence we have that answer is option D, 4 pairs of xy non-negative integers satisfy this. So that'll be all for this video. See you guys in the next video. Don't forget to like, share, comment, and subscribe to our channel to get more hit videos on mathematics. And till then, keep solving maths. Goodbye, guys.